Hello, geometry class, and welcome to this video on two sections, 11.3 and 11.4, that deals with areas of trapezoids and kites and related figures. So we're going to start by deriving the formula for a trapezoid. It's a pretty simple derivation, and it comes from the fact that if I take a trapezoid, I can clone it and flip it, and if I do that, put it right next to the original trapezoid, you'll see that I have a parallelogram. And that's really simple to show. It's too simple to even waste time on. And then I get this section here, which is the same as B2 from the original trapezoid. And this section here, which is the same as B1 of my original trapezoid. And so now the formula for the area of a parallelogram, of course, is base times height. So this entire parallelogram, the area of the parallelogram, is going to be the base, which are the two things added together, B1 plus B2, times the height, which was the original height of the trapezoid. And of course, since we don't have a whole parallelogram, we only have half of it, I can just take half and I can get my formula for the area of a trapezoid is going to be 1/2 the sum of the two bases times the height. And that is where the formula comes from. Okay, so let's apply that formula here. So I'm given that the perimeter of a trapezoid is 35. Now, Smart Notebook only allows me to make isosceles trapezoids without having to do each side individually. So there's nothing in this question that will allow us to assume that the trapezoid is isosceles. But it could be, for all we know. Okay, so we're told that the perimeter is 35, and that the non-parallel sides, the legs, are 7 and 8. Okay, well, now we know for sure that it's not isosceles, but it's close. Find the trapezoid's area if the height is 5. Now, we are actually not going to be able to figure out what B1 and B2 are independently, and that's okay. We don't need that. The area of my trapezoid is 1/2 B1 plus B2 times the height. And I don't need to know what B1 and B2 are. I just need to know the sum. If the perimeter is 35 and 15 of those 35 are taken up by the legs, that means that the two bases by themselves will add up to 20. So my area is going to be half of 20 times the height, which is 5. And that's half of 100, which is 50. So there's my answer here. Okay, so sometimes we're given what the bases are, and in this case we weren't. We didn't need them individually. Together they made 20, and that's all that mattered. All right, here we're actually going to need to find out what this other base is. We are given that it's an isosceles trapezoid, which will help. We are not given the height, and we're given one of the legs. In fact, we're given both the legs are 6. So how can we use that to find the height and to find the other base? Well, the other clue here is that I have a 60-degree angle. One of the base angles is 60. And we're going to see that a lot of the 30, 60, 90 stuff from chapter 9 is going to wend its way into the stuff in chapter 11. Okay, so I have a 30, 60, 90 triangle. The hypotenuse is 6, which means that the small side is 3 and the medium side is 3 times the square root of 3. And that is our height. Okay, so if I start by writing up my formula, and if we were back in school, I would probably make you do this a lot more. Write out your formula and show your steps and everything. We're not, and I'm not looking over your shoulder as you're doing a lot of work. So there's nothing we can do about that. Okay, so anyway, so I'm going to write it out, though, so you can kind of see where things are and you can follow my work. I'd say the biggest thing, and I'm probably going to say this when we go live, in this chapter and the next chapter, is staying organized, especially as the shapes get way more complicated and 3 dimensions and composites and surface area. Staying organized is the key to being successful in these two chapters. Okay, anyway, we have one of the bases. It's 7. Now we have the height is 3 rad 3. We just need the other base. Now, if I draw in the other height, we know, yes, that's still 3 rad 3. In fact, this black triangle is going to be congruent to this red triangle, and that's pretty easy to understand why. They're both going to be 60 degrees and right angles, and the hypotenuse is 6. So angle, side, the triangles are congruent. I'm going to get another 3 down there, which means that this part here in blue is 7, because it's a rectangle, so it matches the 7 that's up there. And now I can see that my second base is 3 and 7 and 3. That's 13. So my two bases are 7 and 13. I have everything I need to plug in. So it's 1/2 of 7 plus 13 times 3 rad 3, which is half of 20, or 10 times 3 rad 3, which is 30 times the square root of 3. And that is the area of my trapezoid. Okay. Onto kites or rhombuses. Now, I don't believe a kite is a rhombus. I think those two are mutually exclusive, and I know that there are some people in the mathematical community that disagree, and that's fine. Anyway, so if it's a rhombus, you can use base times height. A kite, you can't, and so we're going to come up with the formula that's on our formula sheet, 1/2 d1 times d2. Where does that come from? Well, I'm going to break this shape up into two triangles. The smaller triangle on top that I will put in green, and the triangle on the bottom, which I'll put in a school bus yellow kind of color. Okay, and we're going to find the area of those two triangles and add them together. Now, for both of those triangles, they have a common base, and that is D2. So we're going to say, let me just write out what I want to do here. The area of the kite is equal to the area of the green triangle plus the area of the school bus yellow triangle. And so let's start by finding the area of the green triangle. All right, so D1, the first, the blue diagonal gets broken up into two parts. So let's call those two parts X and Y. And we know that X plus Y is equal to D1. We're going to use that later. Okay, so the area of the green triangle is 1/2 times X times D2. And the area of the yellow triangle is equal to 1/2 times Y times D2, right? Because they're both base times height. Okay. So now if I wanted to add these two things together, I'm going to say that the area of the kite is equal to the stuff from the green triangle, 1/2 times X times D2, plus the area of the yellow triangle, which is 1/2 times Y times D2. And now just doing some fancy algebra, I'm going to factor out the 1/2 and the D2. And I'm left with X plus Y. And what did we say X plus Y was equal to? X plus Y was equal to D1. So I can replace X plus Y with D1, and I get my formula, 1/2, and I'll just put it first because I'm OCD like that, D1 times D2. So that is where the formula for the area of a kite comes from. Now, let's use it. Find the area of the kite shown. Okay, just keep in mind that the diagonals of a kite are perpendicular to each other. So I get a right angle there. We're told that this is 4 and this is 9. So my area is going to be 1/2 times D1 times D2. And we already know D1. D1 is 13. So we have to find out what D2 is. And I'm going to find out what this segment is that I highlighted and then double it. All right. I'm going to redraw this triangle off to the side and make it a little bigger. Notice that it is a right triangle. That's unique to this kite. That doesn't happen with all kites. And we are drawing an altitude down to the hypotenuse of that right triangle. And what might come to mind is the similar right triangle, small of the small, medium of the medium, large of the large, that stuff. And this blue piece right here, if I call it H, that turns out to be the geometric mean of 4 and 9. Or I could say 4 is to H is to 9. And H then turns out to be 6. 4 is to 6, 2/3, and 6 is to 9, 2/3. So that tells me that we knew D1 was 13, and now we know that D2 is equal to 12. Right? Because we're just going to double the 6 to get to 12. Okay, so I now have enough to find my area. It's 1/2 times 13 times 12, and that's half of 12 is 6, and 6 times 13 is 78, and that is the area of my kite. All right, so I hope you enjoyed this video. You probably didn't, but I hope you watched it. Maybe that's all I could really hope for, and we'll see you next time.